got any more coming? Well, we'll find out. This is the Missouri Association for Creation Zoo Tour. Ah, there they are. More people coming. And this is, I guess you are group 7? Great. Okay, well, you're the Reptiles, which is, I think, where you're supposed to be. Reptiles are a group of animals that are called tetrapods. Tetrapods means four-legged or four-limbed animals. This includes the turtles, the snakes, the crocodilians, which means alligators and crocodiles, the dinosaurs, and then your first blank, if you're following the question, the lizards. Lizards are the other type I didn't list on the thing. Reptiles are cold-blooded. Now, what that means is we're warm-blooded. We're what is called endothermic. We have our metabolism maintains a certain body temperature. That body temperature is important for us to carry on all the functions we carry on and to carry on our metabolic rate, which refers to the rate at which we breathe, the rate at which our heart beats, how fast we process food, and our cells are performing chemical reactions and so forth. Mammals have a relatively high metabolic rate as a warm-blooded creature. Reptiles are cold-blooded. It's called ectothermic. They have a very slow metabolic rate. So what that means, they breathe slow, their heart beats slow, they live a long time. There are reptiles that are recorded to only eat once or twice a year. That's all they have to eat to survive, to maintain their body function. So contrast that with birds that you just came from. Birds have the highest metabolic rate in the animal kingdom. With like hummingbirds, I think their pulse rate is like 300 to 850 beats per minute. Incredible metabolic rate of birds. There couldn't be two groups of animals more dissimilar than reptiles and birds, but I'm not going to go there today. What I do want to talk about, though, is this idea. Evolution says, oh, reptiles evolved a long time ago, before a lot of the other animals. Therefore, the reptiles are going to be more primitive and simple than the other animals that came later and continue to have functions, features, and complexity. Really, that's not a very good story of what we see. What we see are remarkably complex animals that fit very well right where they are. They are very well suited to the environmental or ecological niche in which we find them, and they have all sorts of wonderful design features that allow them to thrive there. So that's how I look at it, and I think maybe I can convince you. We'll see. Let's just talk about a couple. The green anole lizard, or anola lizard, two different pronunciations. This particular lizard, and they're not alone, several lizards have this trait. They can have their tail removed. If they get into an argument or a fight with a predator, that tail can be torn off. They can grow a new tail. Now you say, oh, that's pretty cool. Wish I could grow a new finger or something. And actually, we're studying how they do this because we'd love to be able to let people grow new limbs. Wouldn't that be great? The green anole lizard, when it's growing a new tail, it involves 326 different genes, at least. That's what they've discovered so far. And they fire according to a very specific recipe to rebuild this tail, because you're rebuilding tissue, cartilage, bone. You're rebuilding the nervous system and the circulatory system. All of that has to come together in just a certain way, and this very specific recipe involving these 326 genes all happens to let this tail regrow. Now, that's not an accident. That's exactly the kind of thing that an expert programmer would put into a design of a system, and that allows the system then to regenerate a lost tail. Let's take turtles. Turtles, for example, have lots of interesting features. When we breathe, our chest expands when we breathe in, and it deflates when we breathe out, right? Our chest cavity changes size as we breathe in and out. Our diaphragm muscle helps that to happen. Well, in the case of turtles, they have a hard shell. That hard shell means their lungs can't expand and contract the same way ours can. So how could they breathe? And the answer is God's given them a special muscular system internally that allows them to move their viscera. Now, viscera is one of those harder words. Basically, it means your guts, your intestines, your stomachs, your internal organs. Turtles can move theirs around with this muscle system they have to make room for the oxygen, to support the act of breathing. So it's one of the special features that God's designed into the turtle to support breathing, because they have this hard shell. Or if you look at snakes and lizards, snakes can sense temperature with their tongue. They can also smell with their tongue. What I really find fascinating about snakes is the venom. The venoms are so incredibly complex in terms of the chemistry. We now know that there's 5 different types of venoms in poisonous snakes. There's the neurotoxins that attack the nervous system. There's the hemotoxins that attack the blood. There's the necrotoxins that will cause cell death and degeneration of tissue, and 2 other kinds as well. What's also interesting, though, isn't just the sort of negative impact of this venom. We've also discovered now, in the case of the black mamba, for instance, there are these specific proteins that are present in the venom that work as pain relievers. And not just an average run-of-the-mill pain relievers. These pain relievers work better than the opiates. They work better than morphine. In fact, they work twice as good, and they don't have the side effects. Morphine tends to slow down the breathing rate. Morphine has other side effects that make it difficult when doctors are managing the pain of a patient. They're looking at these new mambogins, they're called, these proteins that are from the mamba venom, as a superior pain management chemistry to use for people. So I think that's anything but simple. That's anything but primitive. That's actually what I would expect to find as a signature of a creator God who was omniscient and all-knowing, and put that kind of complexity even in these seemingly simple creatures. You know, crocodiles. I didn't talk about them. We used to think, oh, they're just dumb crocodiles. They look at something, bite something. No, they're not as dumb as we thought. Not only do they have these dermal pressure receptors all over their body in the case of crocodiles and around their jaw in the case of alligators, they've now got video of this crocodile that takes this branch from the side of the river and floats out to the river with this branch on its nose, and then it waits. And then it waits. And then it waits. And it waits over an hour. And eventually a certain type of bird that wants to land on that branch comes down, and that crocodile snaps that bird and eats it. What's that mean? He's using bait. He's actually thinking about how to hunt for its prey. We never thought crocodiles were that smart, but they are. God built that into their ability to be that smart to do something like that. Now we have to remember it's a fallen world, and death entered that world when man fell into sin. But God put so much potential into these animals. You know, we see variety in nature, but we see variety all around us. You notice every one of us are human beings, but we all look different. We worship a God who loves variety and diversity. That's just the way He invented the world. And you see that no more effectively than in the animal kingdom. You see all the variety that's built into it. Even a single type of animal, like the dogs. The dogs have all the furry dogs, big dogs, little dogs, less fur, and so forth. So, yeah, there's tremendous variety, and we see that in all sorts of things, even in the reptiles. But the last one I want to talk about, and I think this is a pretty good case for God's creative hand, is the chameleon. Now, the chameleon is a type of lizard. I'm going to just mention 3 special things about the chameleon. Their tongue is amazing. Their tongue is as long as their whole body. In fact, they have the biggest tongue of any tongue in the animal kingdom. And sometimes it's 1.5 times the length of their body. That's the longest that they've measured. This tongue has these special glands on the tip of it that they make this sticky substance. Because what good is it to stick the tongue out if nothing's going to stick to it? They're using this to catch bugs. So there's a sticky substance. There's also a little flap on the end of the tongue. So when they shoot the tongue out, the flap kind of just snaps shut as they get to full extension, just in the mechanics of it. And between the sticky substance and the flap, they can catch a bug. Now, what's remarkable is how fast they do that. This triggering mechanism works in about 4/100ths of a second. The whole thing takes 1/16th of a second for full extension. That's fast enough, and they're accurate enough to catch a fly in midair. You should try to catch a fly in midair. It's tricky. And the other chameleons can do that with their tongue. There's other chemistry involved too, because they have lubricants and other things that support the mechanics of it. It's just remarkable. Second thing about the chameleon, their eyes. Now their eyes look funny to us because they rotate independently on either side of their head 360 degrees. Now that's cool, and it's kind of weird, and it's kind of freaky looking when you watch this. What's really interesting, and what scientists are still trying to figure out, is how its brain can process that much visual input. You see, we have a field of vision, and we tend to concentrate our focus on something within that field of vision when we're looking at it. Now imagine a creature that can look independently in both directions all at the same time, behind and in front of it, all at the same time. The little chameleon brain is processing all that visual information, and we still haven't figured out how he does that. Last thing I'd say about the chameleon, is what they're probably most known for, is they can change the color of their skin. That's kind of cool. They have these special cells in their skin that allow them to change color. Now, we used to think that was because they want to camouflage themselves. Now we know it's more related to temperature control. They can become darker if it's sunny out and they're cold, they can become darker, absorb more sunlight energy, and that'll warm them up. Or they can become lighter and cool themselves off. They also do it because of their mood. If they're happy, they're one color. If they're mad, they tend to be darker. Their mood, and if they're in mating season, all of those things influence their coloring. But here's what I want to show you some pictures of some chameleons. And have you help me see if you can see what I think I'm seeing in these pictures. This is the head of a chameleon. Just one particular color pattern. And what I'd like you to notice, look at the eye of this thing. See those little lines going into the center of the eye? Now, here's your options. Dumb luck. If you were putting on your makeup without a mirror, would you get it that good? No. Dumb luck evolution doesn't have a mirror. It doesn't have a purpose other than natural selection. And yet it comes up with beautiful things like that. Option 2, a creator God designed this to be a beautiful thing. To me, that looks like the handiwork of an artist. That's a better explanation, I think, that, oh, look what accidents created purely for natural selection. So, that's just one. I got a couple here. Another beautiful, again, I see this as the work of an artist. Far beyond what is needed to survive in nature, we just have a remarkable demonstration of God's creative power. I think this one may be a happy one. What do you think? He looks pretty happy. I can't really tell for sure. I don't know that much about chameleons in terms of everything about their colors, but that's a pretty interesting look. On the other hand, I can't tell on this one. He's got an interesting color pattern. Again, they can change this up. That's what you need to remember. He can change to look like this. That's the power that the chameleon has. What I also like to point out, see, he's got the opposable digits. He's got like a little hand. Now, if this was in the primate world, they'd say, oh, look, there's evidence going to thumb, opposable thumb. He's on his way to evolve into a human. Because it's a lizard, they don't try to make a point like that. Most of evolution is made up of stories that pick and choose the evidence to support a particular story and ignore all the evidence that doesn't support that story. Well, here we find opposable digits that help the chameleon live in trees. Why is that good? Well, they don't have to compete with all the lizards running along the ground who are eating bugs on the ground. They get to get their bugs up in the tree. That's kind of nice for them. Here's the green and old lizard I talked about, the one that can lose its tail and regrow a new tail. They live in trees also. They also have the opposable digits. Again, that helps them grasp branches and get their food and their livelihood. They're called arboreal lizards because they live in trees. Any questions? Yes?
What about a basilisk?
A basilisk lizard? I'm not familiar with that.
They can run on water.
Yeah, pretty cool. I've seen that. Special feet that let them travel across water. Yep. Remarkable stuff. And I would say anything but simple and primitive. Actually very complex. Other questions? Did everyone get the answers they needed for their sheet? Okay, well, I think that's it. Our time is gone. I'm going to send you on to the primates, which is the next stop right up the hill.